Good afternoon. So my name is Richmond Forsen, and I'm from Hangzhou Foreign Language Schools. And I've been with Nippon for, I'm in my fourth year now, and I teach A-level economics and business. Okay? So this will be the contents of today's workshop. So we understand why A-level maths and economics can be integrated. We also understand the basic skills required from maths that we can use in A-level economics. We understand how we can apply maths in economics. We also talk about professional development recommendations, and we talk about the conclusion. So undergraduate economics incorporates significant amounts of mathematics and statistics, regardless of which country you are. Okay? Why do we have to integrate A-level maths into A-level economics? Universities demand both analytical and quantitative skills in economics. A-level subjects often are taught in isolation. So those of us who have colleagues teaching A-level maths, we could see that they teach A-level maths with no application to economics. In the same way, those of us teaching A-level economics, we teach A-level economics with no application of what they have learned in A-level mathematics. And Chinese students kind of find it difficult to connect these two if you don't tell them. So there are times students will come to my class and I'm doing a basic simple differentials. Even though they have taken those subjects or those topics in A-level maths, they kind of fail to appreciate what is the use. For them, they are just interested in the numbers, but they cannot really apply in economics. So integration will enhance students' readiness and make them critical thinkers. Okay? So we are basically going to know how we can integrate these techniques. And this is relevant because it will help students to connect the two, connect A-level maths. And we are quite lucky that in China, most students are already taking A-level maths. So we are not the one to teach them the mathematics. What you are supposed to do is that you are supposed to apply them. Okay? Try to remind them that, oh, you did this topic in A-level maths. This is how we can use it in A-level economics. Okay? But again, we can do this when we take advantage of our high ability students. Okay? So some of these techniques, we can rely on our high ability students. I'm not saying that when you go back, you should focus on teaching math, no. We should always also have in mind that we have a target to achieve, right? We want our students to get A stars and all that. So if you want to take advantage of your high ability students, there's an opportunity for us. Because there are times I get a lot of students who are taking lessons outside, coming to me with some questions that are not captured in the syllabus. Those are the times you have to prove yourself or defend yourself. So some of the tools required to be used in economics, we are going to understand how to interpret and construct graphs. This one we all know already, so it's basic, okay? We're also going to understand how we can apply basic calculus. And my focus is going to be on the second point, okay? We can also focus on statistics for demand and forecasting. And also how we can use algebra for modeling economic relationships. For example, when you're talking about the accelerator theory, where we normally state that demand for capital is being derived from demand for our need to produce, right? We can simply use an algebra to model this kind of relationships. So students will not always have to remember or have to memorize that the capital output ratio should be constant, this should be that. You can just use a simple algebra so that when they can capture that algebra, they can always remember. Because our students kind of memorize a lot without understanding. So once they are done with the examination, when they move to the next level, like they don't remember anything because they memorize. They don't appreciate what they are learning. All what they focus on is that they want to get an A, and after getting an A, it ends there. And to me, that is not how education should be. Okay. So when I was in university first year, my professor told me that in economics, we walk on 3 legs, okay? We walk on 3 legs. And what he meant by 3 legs are that in economics, you do theory, you do graphs, and you also do mathematics, Okay? But the Cambridge curriculum has been designed to focus on only two legs. We do theory and we do graphs. The mathematical aspect is missing. Okay? And that is what I'm going to focus on today. Okay? So these are the three basic skills that we required to do economics. You need a theory, you need the graphs, and also you need the mathematics. So, for example, we all know what is market demand, right? We all know, we always tell our students that market demand is horizontal summation of the individual demand curves. We tell them that on the surface, horizontal summation, what does it mean? These are Chinese students. English is not their first language. But we tell them that market demand is horizontal summation of individual demand curves. They memorize that. But on the examination condition, they will forget. And they will end up saying that market demand is summation of individual demand curves. In fact, if you say the summation of individual demand curves, you are not 100% correct. Because summation can come from the vertical side, as can come from the horizontal side. Okay, so the keyword here, you normally say that it's a horizontal summation. But what is on the horizontal axis? We know it is a quantity, right? So this is, for example, this is individual A, individual B. These are their demand curves. Okay? And these are their demand equation, these are their demand curves. Okay? This is for individual A, this is for individual B. So when we say it's horizontal summation, we expect to sum the quantity axis, which is the x-axis, right? So if we do horizontal summation, demand curves can be presented in a direct or in an indirect form. So whatever we see on the board today is a direct demand function, because we have expressed the equation making the quantity the subject. Okay? So this is telling us that when price increase, our quantity demanded is going to fall. And when price decrease, our quantity demanded is going to increase. That is the law of demand, right? That is the direct demand function. So when we say horizontal summation, we are basically summing the quantity axis. So here, 30 plus 60 is 90, 0.5 plus 1 is 1.5. So we sum this and we tell them that this is the market's demand curve. In one or the other, when I was in uni, the professor will not give you this kind of demand curve. The professor will show you an indirect demand curve, where price has been expressed as the subject. So for example, you see P equal to, let's say, 20 minus 0.5 Q. And most students will end up summing the indirect demand curves. And that is wrong. I'm going to show you an example of an indirect demand curve. So when we define what is a market demand to our students, we have to let them know that we can also express this in mathematics. And what will help them to remember the word horizontal is that on a demand curve, the quantity is represented on the horizontal axis. That is why we normally say it's a horizontal summation of the individual demand curves. So we can just use this simple equation to reinforce the understanding of the theory. Okay? So now, this is going to be my main focus for today. In economics, we normally say that economists take decision at the margins, right? We normally say that in economics, we take decision at the margin. What does it mean? What does it mean when we say economists take decision at the margin? Anyone?
Before consuming the additional unit, reducing the additional unit, we compare the cost and the benefit, the revenue, and it applies to consumers and to the firms.
Yeah, that is great. That is great. Let me tell you something funny. When I was in the uni, and the professor told us that in economics we take decision at the margin. You know, in the notebook, when you have a notebook, notebooks always have a margin, right? Yeah. So we thought the professor is going to tell us that we shouldn't write in the margin. That is what we thought we shouldn't write in the margin. We need to understand what it means. But basically what it means is that, I mean, whatever you said is right.
And instead of summing up everything at the end, get the total at the end, because we talk about the rational behaviors, that is an assumption.
Yeah.
So before taking the next step, you weigh and you calculate whether it is worth it in terms of satisfaction, in terms of cost, and then you look at it.
Yeah, that is great. Okay, so basically what it means is that in economics, anytime we want to take a decision, we think about our extra benefits. That is the margin. Okay? We always think about the extra benefits or the extra costs. We always think about the extra. Okay? So the margins is nothing but the difference. Okay, the change. That is what we call the margin. And if you look at all the economics basic equations or the function, for example, we know what is total products, right? We know what is marginal products. We know what is total utility. We know what is marginal utility. We know what is total cost. We know what is marginal cost. Those marginals are basically from differentials. Yeah. And these are topics that are being taught in A-level maths. So on the surface, we kind of tell the student that, oh, this is the formula. For example, marginal product is change in total product over change in change. And they memorize the formulas without understanding what they are doing. Okay, and some of them cannot even recall that, oh, we have done this in A-level maths. They can't even remember because the students, they study each subject in isolation. They go to A-level maths, they study. They come to A-level economy, they study. They cannot connect the two. But most of the things we do in A-level economics have been done in A-level maths already. So this is the time for us to probably coordinate with the math department and other departments so that they can make our job easy for us, right? So we are going to understand how we can introduce differentials in economics. And our students are more used to this, right? Delta. That is what our students are more used to, right? But we can also use this D to represent differentials. We can also use this partial D to represent differentials. So for example, I mean, not only in China, if you don't introduce this and introduce this or this, they don't seem to understand what is happening in the classroom. We have not seen this before. All we know is delta. We don't know this or we don't know this. So it is the time for us to let our students know that differentials cannot be represented by only delta, right? Can represented by D or partial D. And
we are teaching math, we use the D first two letters so often, and our students tend to lean on more delta. Because now it's even in math class, they lean more on delta no matter how much you make them. I think it's a habit that comes from the Chinese curriculum.
Yeah.
They don't change to that. Yeah, they write delta, even in physics, they are used to writing delta a lot.
Yeah.
But that should be used only in this introduction.
But I'm sure I've seen the A-level math curriculum, and I hardly see delta in the curriculum.
No, we don't use delta. We use that mostly in physics and
Okay.
But we prefer using D in math.
Yeah. So those teaching A-level maths, or I mean, those of us teaching A-level economics, trust me, students have seen this and this in A-level maths. They have seen it because it's in this curriculum.
And this topic comes towards the end of the year.
You mean economics? You mean economics?
Maths.
You mean maths, right?
Yeah, in maths.
Okay. You
And
mean
towards
in
mid-year, they study differentiation.
In which year?
A-level.
In which year?
AS
In the final year of high school?
AS, right?
Yeah, but if they are doing 0580 basic math in IT, then they would have never seen this simple level.
Yeah. So I'm teaching A2 economics, right? Those are people who are university ready learners. So those are the people we should take advantage of. I mean, we can try to introduce those doing AS into it, but we shouldn't expect so much from them. Okay? So you're going to understand the basic rules of differentials. So I'll focus on the first three rules, because that is the basics of that we need. Okay? So the first rule of differential is is what I call the constant rule, which everybody know. Okay. So we have the constant rule. So for example, if f is a function of x, and fx is equal to c, where c is a constant, then if you're asked to find change in a constant, I mean, we all know a constant does not change, right? Change in constant should be equal to 0, right? Good. So, a constant does not change. So, differential of f with respect to x, which can also be represented by f prime. Okay, if you see f prime, it also means phase differential. If it's second differential, you see f prime prime, right? So f prime is equal to 0, it means the change in the constant is equal to 0. That is two mathematics, right? Okay, so now let's see how you can use it in the economics. So for example, assuming that you have a demand function, then we know in demand function we have the autonomous demand and the marginal, right? Or the propensity side. The autonomous side does not depend on the price or anything, right? Because even if you don't have money today, you're still gonna eat, you don't die, right? Good. So assuming that our demand is giving us this.
So you're talking about consumption function basically. I'm going to link it to consumption function.
Yeah, we can also link to consumption.
Function.
Yeah. Good. So assuming this is our demand function, okay, a function of price, and it's equal to 9. And we are asked to find the slope of the demand curve, or how quantity demand responds to changes in price. You basically write the change in quantity divided by change in price, which we normally write delta QD over delta P. We say this equal to 0. So this can tell us that the figure here, the demand function here, is a constant, so it shouldn't change, right? And when we are calculating the elasticity, this is the slope of the elasticity. We're going to talk about that. So the first rule of differential, which is the constant rule, this can tell us that differential of a constant is equal to 0. You will appreciate it more when you move forward, okay? I have more examples to introduce you.
No, but here if we take it as constant, that means there is no change in price. The price did not change.
The price does
Price
not
is
affect.
zero.
Yes.
If
Price
you
does
say
not
it as
affect.
0, that means product is, it does not have any price. Or
No.
are you talking about there is no change in price? Are you talking about the gradient?
Yes, you're talking about the gradients.
There is no change in price.
Yes.
And
But the change in price does not affect the quantity.
okay.
Yeah.
So there could be change in price, but there's no change in quantity.
Yeah. So think about a demand curve that is perfectly inelastic.
Yeah, perfectly inelastic.
Okay.
Quantity demanded is not responding at all.
Yeah.
Any change in price.
Right.
But
And
here,
this
what
is
is the
how-
variable, this OP or BP?
Which one?
I mean, at the Q, the function,
It's a function of price. We know quantity demand is a function of price. But here, price is not in the equation.
And this 9 is a constant.
A constant. As you move forward, you see more equations. You appreciate it more. Which the 9 there we call the intercept. So even at a price of 0, you still buy something, right? You will see more. So let's take our time. Yes. So basically means a change in a constant is 0, okay? You will see more. After we're done talking about the power rule, we combine the two, okay? So this power rule basically also tells us that if you want to differentiate a function which has a power, you basically have to multiply the number or the variable by the power and subtract 1 from the power. That's the phase differential. And this rule holds for all real numbers, okay? So for all real numbers. So here the power is n, and here x is a variable. I'm using x. I don't want to use figures because I want to make it more general. Okay? So I use x. So here the power is n. So you multiply this x variable by n, then you subtract 1 from the power. That is the power rule, the phase differential. Okay? So we have n times x to the power of n minus 1. Okay? That is the power rule. We are going to understand it more when you move forward. Okay? So example, if our demand function changes to quantity demand as a function of price is equal to e to the power of 3, you have to find a change, how quantity demand responds to changes in price. You will do dq over dp, or change in quantity of change in price. Here the power is 3, so you multiply price by 3, and it subtracts 1 from the power. So here we have 3 times e to the power of 2. Okay? You're going to appreciate this more as you move forward. Okay? But I want you to have the rules in mind. Okay? Is that okay?
And will this give us a straight line demand curve?
Say again.
Will this give us, through this equation, if we plot it, so do we get a straight line or a linear demand curve?
No, this will be, for example, we have different types of good, right? So this is an exceptional,
Linear demand curve.
this is an exceptional demand curve, something like a given good.
Upward sloping.
Yes, something like a given good. It has upward sloping, but it will start from the 0 because there is no
Even
intercept.
for the different goods, it is a linear demand curve, no?
It's an upward sloping stream. It's an exceptional demand curve.
Doesn't have to be
Again? Yeah. You focus on the slope. You focus on the relationship. So at this point, you focus on the relationship because the slope here is positive, right? It's 3p to the power of 2.
Yeah.
Okay? So don't focus on downward sloping.
It's
If
upward
it's downward
sloping.
sloping, it should be negative. So at this point, you focus on just the slope. Okay? So now let's see how we can combine the two. Okay? So this is a typical demand function. You have all seen this before, right? Where we have quantity demanded is equal to 30 minus 0.5. It is a typical one. Okay? When you are asked to find the slope of this demand curve, you're basically asked to use phase differentials. Okay? So you can see this demand curve has two components. It has the constant components and it has a variable component, which is 0.5, right? So you have the constant components, okay, which we can use the constant 2 on it, okay? And we have this component going to the power on it, okay? Yeah. So if you are to find the slope of this demand curve, we'll be having, we know differential by constant is 0, right? So if you differentiate 30, you get 0. If you differentiate the second part, remember this p has an exponent of 1. So you multiply the 0.5 by 1. Okay? You subtract 1 from the exponents. You have 0.5 times 1, p to the power of 1 minus 1. You get negative 0.5 to the power of p to the power of 0. Okay, and any number to the power of 0 is 1, right? So you could see that the slope of this demand curve is negative 5. Trust me, our students know this already. Okay, our students know this already. This is the basic to them. So whatever we're supposed to tell them that the slope of a demand curve is basically from the phase differentials. We don't just have to tell them that it is delta QD over delta P. Okay? You have to know what does it mean. Is that clear? Is that clear? Is that too confusing? No, right? It's okay if it's too confusing. When you go back, take your time to digest. Okay?
I've forgotten how this applies to constant rule. What's the constant rule thing happening here?
Differential of the constant is 0 because there is no variable attached to the 30. The 30 is the constant. There's no variable. Yeah.
Okay.
The differential of the constant is 0. So it just goes. Okay?
So then this negative sign means that there is an inverse relationship.
Yes.
So that
This means the
inverse
demand curve slope
relationship
downwards.
can be proved.
Yes. So the demand curve will slope down. This is a normal demand curve. Okay?
So you only use this part in economics all the time, or do you have more
I don't get it.
like do you only use linear curves?
No. So those of us teaching A-level economics, we know our syllabus is packed, right? So you have to strike a balance of when to use some of the concepts. And also depends on the kind of questions you get from the students. Okay? The A-level economics, you're not supposed to go there and prove to the student that you know, right? But some of the students will be asking you some questions that will be challenging you. That is where you have to rely on this kind of techniques. Or maybe when you have some exceptional students in your class who always want to be ahead of the lesson. These are some of the things you have to let them to differentiate them from the class. Is that clear? So you don't have to be doing this in every lesson that you do, but it can help you differentiate. Okay, it
And I
helps
ask
you do
my
differentiation.
students that please discuss with your maths teacher about it.
Say again?
When my students, I had some of the Chinese students in my class who would try to prove everything mathematically.
Okay, to
And
discuss
then
your
I
math
used to
teacher.
say, okay, I had a maths teacher,
They should
fantastic
study
maths teacher
calculus.
from Kenya, Mr. Daniel. So
Yeah.
then I would tell my students, okay, in Mr. Daniel's lesson, please ask him about this.
I do the
Yeah,
same
that is
thing.
all
Come to
fine.
my
Go
calculus
talk to
course.
Will.
Yeah, that is all fine.
Coming to us.
This thing we will resolve for you guys.
Yeah, that is also fine.
But you should say that delta P approach is zero.
Which one?
The delta P
Yeah.
approach is zero. So like there's a difference quotient, that's the derivative. But you don't go into that, right?
Yeah.
In the course.
Yeah.
But I know Mr. Even if you learn
Yeah,
this.
yeah, you can do discuss. You just
So it's
apply
not fully
it.
precise actually.
Yeah.
Limits.
So we are not doing core material, we are applying the techniques. Okay.
I think it
So-
can be more a part of IB classes where they focus on creating interdisciplinary links.
Yeah.
Over there, it's more, I think, useful. Or either we can have this topic to be co-taught by a maths teacher and the economics teacher, where the economics part is done by me and maths part is handled by maths teacher.
That's great. That's great.
But again, like your science students mostly cannot apply math in other classes. The
Yeah.
minute they go to other class, they don't want to think about math. They
Yeah.
cannot
Compartmentalized
connect.
learning.
Yeah.
Yeah.
They
Just
might
only the
know
good
you-
ones, they want to
They
think
will
about
use
math.
dy over dx every day. But the minute you put delta p over delta x
Yeah.
something, they will not think about it.
Yeah, I mean, but there are times you get some exceptional students coming to you. These are the times, okay? So we can generally represent the demand function in this way, okay, where the A is a constant because there is no P attached, and the B here is the slope, and the P is the price. So we can plot it like this, okay? So this is actually the slope of the demand curve, right? Changing here or changing here with the slope. Right? So this here we call it a direct demand function, and here's an indirect demand function. It's an indirect because here P is the surface. That's the basis, okay? So normally, when we do change in Q by changing P, whatever we get is an inverse of the slope. It's not the actual slope. Okay, if you want to get a direct slope, it's from here. You can see it's changing Q by changing Q. But you normally write changing Q by changing P in the elasticity formula, right? That is the inverse of the slope. You know what I mean? So this is a direct demand function, this is indirect demand function. Okay? And when you plot this, how it's gonna look like. So here the slope we all know is basically negative b, right? The slope.
Thank you.
Okay. So we can move on, right? I have a lot of slides. So let's move on, okay? I mean, you can't understand everything in here, okay? I just introduce you to some techniques that you
Can
can
you
use.
talk about the elasticity concept?
Yeah, I'm going to talk about it, okay? Okay, so the third row is the product row. This is a little bit, it's easy, but it might sound complex to you because you also have this rows in line, but it's not complex, it's easy, right? You can do it. So, this is product because we have two variables or two different functions. We have f of x multiplying q of x. Okay? This is multiplication sign, okay? This is multiplication. So the product rule is that you have to hold the first function constant. Okay? You hold the first function constant. you hold the first function constant and you differentiate the second function. And because it's multiplication, we change this to addition, okay? So you hold this first function constant. We hold this first function constant and we differentiate the second function. So if you see G prime basically means that you have differentiated this function. Okay? Plus, now we hold the second function constant and we differentiate the first function. So we have f prime x. So this is basically the product rule. And this rule can be used to do a lot of things in economics. A lot of things. So we're going to talk about the elasticities and the relationship between elasticity and revenue and all that. You can use this rule to do all that. Okay? So this is the product rule function. If you don't remember, it's okay. You don't have to remember, okay? When you go back, you can take time. In your free time, you can look at them, okay? So now let's look at the elasticity, okay? This is the popular formula almost every Cambridge student know. Okay, and in a multiple choice, they kind of come across this. But one interesting thing to note is that when Cambridge is setting multiple choice questions, they don't give the figures to the students in percentage. They give it to them in absolute terms, not in relative terms. So now most students will now have to convert the absolute figures into percentages before they calculate elasticity. That is a complete waste of time. So students will end up saying that, oh, the time was not enough, it's not enough, but it's because they don't really know how to apply the mathematical concepts. Okay? So this is a popular equation or formula known by every Cambridge student. We said PED, price ratio demand as percentage change in quantity demanded by percentage change in price. We can express this in a simple form. Because Cambridge is not going to give you percentage change in quantity demanded. Cambridge is not going to give you percentage change in price. Cambridge is going to give you Q1 is equal to 2, Q2 is equal to 4, P1 is equal to this, P2 is equal to this. Now you have to find the percentages before you do this, right? So we know that when you want to find rate of change or percentage, it's basically given as change in Q over Q. That is rate of change, right? The change, the new quantity minus the old quantity divided by the old quantity, the rate of change, right? Those of you teaching inflation, the CPI, these are the formulas, right? So change in K over Q divided by change in Q over P. This is the rate of change. This is the percentage change quantity minus percentage price. Okay? This can be expressed in the same form as this. Okay? So I basically change this division sign. Okay? This division sign here, I use this sign. Okay? So I've not done anything new. Exactly? There's nothing new here. Just this division sign, I use this. Okay? So changing Q over Q divided by changing P over P. Okay? This can also be rewritten as change in Q over Q times P over change in Q. So I basically change this division sign to multiplication. And I inverse it, right? Because from the multiplication or right. So now we can rearrange it. Okay? So multiplication does not follow any error of transposition or when you change the place of the verb. 2 times 6 is not 6 times 2, right? It doesn't change anything. So we can bring this change in P here. Okay, so you have change in Q over change in P. You can bring this change in P here because they are multiplying, so it's the same, okay? And you can bring the change in Q here. So we switch this, okay? So this comes here, Q goes here. So now the pair becomes change in Q over change in P times P over Q. Always take note that this P here, this Q here, are the initial price and the initial quantity. Okay? So, in multiple choice questions, if a student knows this formula, all the student needs to do is that he take his calculator and punch. In less than 30 seconds, the student should get the answer, take and continue. You don't have to calculate percentage before you come and do the final answer, right? So most students that I've come across, they are used to this formula, but they don't know this formula. But this is what they say. Okay? So let's try to introduce our students to this formula also, because this will help them a lot when answering multiple choice questions. Okay? Is that clear?
We use it for, for the budget line and all that.
Yeah, we get it. Okay?
Yeah.
We get it. Someone is moving along with you. Okay, so this is the third formula, okay? Third formula. And take note, it is important to take note that the Q is the initial quantity demanded. Okay? The change in Q is giving us the Q1 minus Q0, or the new quantity minus the old quantity, okay? And the change in P is also the new price minus the old price. And this P and Q are the old price and the old quantity. Please take notes, because if a student uses the new price and new quantity, they get it wrong, okay? So take notes of that.
Then it will be slope of the budget line.
Yeah. So graphically, this is what it looks like. Okay? This is what it looks like. These are demand functions. This is price elastic. This is inelastic, right? We have the P1, P0, okay? The new price, old price, new quantity, old quantity, okay? So students can easily write Q1 minus Q0 divided by P1 minus P0 times P over Q to get the answer. They don't have to now think about finding percentages and all that before they get the answer. Is that clear? Now, let's talk about elasticity again. Any question?
Yes, I have a question about it, and I faced this question here in China.
Okay.
My students back in the country never asked me this question.
Okay.
So we just used to tell them, and they used to follow us blindly, that on a linear demand curve, in the middle PED is 0.
Yeah, that is
But
elasticity.
here, one of my students in AS, he took numbers, and he did calculations, applying this formula of elasticity, and he could not find out a value which is 0.
Okay. Because we normally focus on a point, right?
Yeah.
But that assumption is not based on a range.
Yeah. So I think that we need to use the formula, a different formula that is for point elasticity. This
Yeah.
formula is not for calculating the point elasticity.
So I'm going to show you why. I mean, in the model, it is still 0. Elasticity is still 0.
Yeah.
It's a geometry, right? I'm gonna show you why. Okay, you understand it here. Okay, so let's look at this. Okay, so when our students are writing essays, they have to do evaluation, they have to do analysis and all that, right? There are times they have to connect revenue to elasticity and all that, right? And this kind of cuts across most of the topics. You can cut across from utility, go to market structures and all that. You come across there. Okay, I remember when we are grading students, at times I'll have a meeting with Sean. Sean is here, my HOD. Sean tell me, Richmond, this student did not connect. Let it like this, let it just because we always want to make sure we connect, right? So this graph here shows the relationship between elasticity and total revenue.
Yeah.
Students have come across this a lot. And there are a lot of graphs in economics, and in examination condition, most students tend to forget. But we can simplify this relationship with a simple equation. Okay? So here, whatever is going on in this can be shown here. And Sean and myself, we mostly tell our students or summarize this relationship using this acronym. So we tell them EOIS. There are times I introduce students to this, and when you're getting to the end of the syllabus, you try to connect this again, and you write this acronym on the board. It's like you have not seen it before. It's like you have not come across it before. And you always tell them that elastic opposite, inelastic same. Okay? You tell them like elastic opposite, inelastic same. And the idea here is that we think about what happens to revenue when there are changes in price. And you connect this with elasticity, okay? So we know that the question our dears asked was this side, right? Yeah, so here we know here is elastic, unitary and inelastic. And you know here total revenue is rising, okay? Here is the maximum and here is falling, right? And we can represent it using this marginal revenue formula. We are going to understand more of this. Okay, and maybe this will answer the questions to the students in your whole country, right? So you said you're in China, right? You can use this to simplify for them. So let's try to focus on this, okay? It's a little bit confusing, but it's pretty much easy, okay? If you move along with me. So let's look at it. Let's look at this. So this is our demand function. This is our marginal revenue. And imperfect competitive market, for example, right? Because in a perfect competitive market, the demand curve is the same as the marginal revenue, same as the average revenue, because they act as price tickers, not price makers, right? So on an imperfect competitive market, this is how the marginal revenue curve looks like. Just twice.
There's a divergence between the two curves.
Yeah, just twice steeper than the demand curve. We come across that on my slide. Okay, so let's try to understand how we can connect elasticity to summarize the relation between revenues. Okay, so you remember we are talking about elasticity and what? Revenue. So it comes from two things: revenue and elasticity. Right? So let's review this key concept. Everybody here knows total revenue given as price times quantity, right? Basic. Everybody here knows marginal revenue given as change in total revenue by change in quantity. That is the first differential thing we did this morning from the beginning, right? So this is first differential. Change in total revenue by change in quantity. Everybody here knows the formula for elasticity. I just did this, okay? Change in quantity by change in price and price by quantity. So we can use this and this to derive this to summarize the relation between revenue and elasticity. Okay? So remember, we are talking about the relation between revenue and elasticity. So it comes from revenue and elasticity. So this is revenue, total revenue, marginal revenue, elasticity. You can use this to get this. Okay? Now let's look at it. So step one, like I said, total revenue is given as price times quantity. Right? So you all know P, okay, price as a function of quantity demanded. Okay. We have Q is the quantity sold. Then when we have revenue, we need the marginal revenue. When you have total revenue, we need the marginal revenue. How do we get marginal revenue? From first differential. So remember I talked about the product rule. Right? So you can say this is product rule, right? P times Q is product rule. So we're gonna use the product rule. It's okay if you don't remember the product rule, okay?
Sum of marginals will give total.
Say again?
I'm saying sum of marginals.
Yes, we'll give you total. Yes. Sum of marginals the total, okay? Good. So, and that is the integral. Okay?
Exactly.
So the inverse of differential is integration. Okay? So we know marginal revenue is a derivative of total revenue with respect to quantity. Okay? So we know it is given as change in T by change in Q. Remember TR is given as P times Q. So I basically put P times Q in place of TR. So I'm not adding anything in here. Okay? So now using the product rule in A-level math, they know this. Okay? They know this. So what we do is that we're going to define marginal revenue using the product rule. Using the product rule on this. Okay? And the product rule tells us that we have to hold the first variable constant. Remember? And we differentiate the second variable. Okay? Plus, we hold the second variable constant and we differentiate the first variable. Okay? So again, we hold P constant. So P, we hold the P constant. Then we differentiate quantity with respect to quantity. Because remember, marginal revenue is a function of quantity. Okay? So P, we hold constant, we differentiate Q with respect to Q. Now we are done with the first part. Now because of multiplication, we introduce plus. So plus, we hold the second part constant. Okay? Then we differentiate the first part. Change in P over change in Q. Is that clear? It's simple, right? Now, here Q, you can cancel out. So this can be written as P equal to Q times change in P over change in Q. very simple, right? For the product rate. Okay? So let's continue. There is something interesting to see here. Look at here very carefully. And I'm going to ask you, where can we find this? Based on our relationship. Okay? So this is our equation 2. Okay? It's from the previous slide. Okay? So step 3. Remember, we are talking about the relation between revenue and elasticity. Okay? So we are now done with the revenue part. Let's look at elasticity. Okay? So define price elasticity of demand. Okay? So if you know this, elasticity you can change in Q by change in P times P over Q. Right? Can you look at something here? From equation 2 and equation 3, you could see that this section is inside here.
Just the inverse of that.
Exactly. You could see that, right? You could see that change in Q by change in P is basically the inverse here. Okay? So now what we have to do is that from the elasticity formula, we have to find change in Q by change in Q and put it here. Okay? So you can see that this, they are the same, just that this has been turned upside down, it's inverse. Okay? So now what we do is that we find change in P by change in Q from equation 3 and we substitute back into equation 2. Okay? Is that clear? Okay, it's okay if you don't understand. When you go, you take your time to understand, okay? So we find change in Q by change in Q from this equation, we put back into this equation. Okay? So we can rearrange this to express dP over dQ in terms of elasticity, okay? So we are taking inverse. Remember this is dQ over dP. So you want to make it dP over dQ. So we take inverse, right? So if you take inverse, you basically write 1 over elasticity. That is the inverse. We turn it upside, okay? So we take inverse, then the equation switch. dP comes up, dQ comes down. Then we have Q over P. Okay? Now we divide both sides by Q over P. Remember, because we want to find dP over dQ. Okay? So we divide both sides by Q over P. So we have dP over dQ equal to 1 over epsilon means the elasticity divided by Q over P. Okay? Now it's division, so we change multiplication signs, right?
P over Q.
Exactly. So dP over dQ is equal to 1 over elasticity times P over Q, which is equal to P over Q times elasticity, right? So now we can take all this equation, and put it in the equation to read the marginal revenue function. You get it? Good. Because remember now we know what is dP over dQ. It's equal to P over Q times epsilon. Okay? So now we substitute dP over dQ, which is equal to P over Q times elasticity to the marginal revenue function. Okay? Remember the marginal revenue function is this. Okay? Marginal revenue function is given as P times Q over dP. This was the equation 2. And now we know what is dP over dQ, given as P over Q times epsilon. Okay? So we basically put this in place of it. So we have P times Q, P plus Q times P over Q times epsilon, which is here. Right? So now, this is multiplying, so this Q can cancel this Q, right? Okay. So this Q can cancel this Q, so we simplify it. This Q cancels this Q, and you have P plus P over epsilon. Now P is a common variable, so you can factor out, right? So you factor out P. So you have P to bracket 1 plus 1 over epsilon. This whole equation is all you need to understand the relation between elasticity and revenue. This is all you need.
Can we put it this way? If we go back to that slide where you were showing the graph, there was a divergence gap between MR and the demand curve or the other one. If you please go back to that slide. And on the bottom of that, there was that total revenue curve.
Yeah.
I mean, I just have this confusion in my mind. It's not to question you. You have an absolute knowledge. I can't compare with your knowledge. Yes, on this graph, there was another graph where there was a gap between the MR and ER curves. Here, this one. And if you put that total revenue curve at the bottom of this graph, so then there will be link between three variables. Elasticity in the middle, which is unitary. Then this is marginal revenue, which is 0. And at the bottom of that, total revenue, which is at the maximum.
Yeah.
So these three connections.
Exactly.
So, I mean, I know that when there is no change, that means total is at the maximum.
Yeah. Yeah.
How do we link it to the unitary elasticity at this point?
Okay. So we understand it from this relationship. So now we're going to assume.
Gotta go, it's checkout.
Sure. Now we have to assume different elasticity figures for the elastic. So you're going to do for elastic, inelastic,
And
and
this was
unitary.
my earlier question as well, that when we take numbers and we try to prove that in the middle, PED is unitary,
Okay.
so by using that PED formula, we aren't able to prove it. We don't find a unitary value there.
I think we
I mean, I
can.
understand the relationship between MR and TR, but how do we connect it to, and how do we prove it mathematically that PED is unitary at that time?
So let's look at this interpretation. Okay. So you come back. Okay. So now we know this is our relationship between revenue and elasticity. Okay. So now let's assume a price for a price increase. Okay. So you know from the basic law of demand, right? When price is going up, what happens to quantity demanded? It falls, right? And when price is falling, what's happening to quantity demanded? It's increased, right? So let's assume a price fall. A price fall. So if a price is falling and demand is elastic, okay, there's an elastic demand. Okay. This sign is less than because it's negative. Okay. The same when it's greater than it's positive. Okay. So when demand is elastic, when price is falling, we expect our quantity demanded to go up, right? So this arrow going up here is when price is falling. Okay? And this arrow going up here it means when price is increasing. Okay? So when price is falling,
And demand is increasing.
Increasing.
Total revenue will increase.
exactly. I can share this file with you guys if
Can we take a
you're
picture?
It's great.
interested. So
Have you checked out, Kurt?
Yes, I did.
So
Okay, I'm gonna go down and do it now.
interviews, right? So this is something. So we have been participating in the interviews, and I read most of the students' personal statements, and most of them write about having idea in econometrics, having idea in how to code. So ideally, during the interview, and going to the university, they are more interested in research aspects.